What's up guys, Talha here again, and today what we are going to discuss will be about discrete mathematics, and this was the class that we took today, and this was our first class, and I prepared the slides that we are going to discuss today. So discrete mathematics is the part of mathematics which is different from the calculus, which is different from the normal mathematics we study. So today our topics will include introduction. So first of all, what we'll do is introduce what is discrete mathematics and how it is different from calculus, which we have studied in our previous classes. Then we are going to jump on to sets. What are sets, and how do you write sets? What are the different ways of writing the sets? And then lastly we are going to discuss what are equal sets and what is the condition that is necessary for the sets to be equal. So first of all, let's jump on to introduction. So calculus. So in calculus we have previously studied. In calculus we studied differentiation, we study integration, we study limits, continuity, discontinuity, and all of that stuff. So we studied that in calculus. In discrete mathematics we study just the discrete numbers, or the so in discrete mathematics we study the discrete structures, or you can say the finite or concrete structures in discrete mathematics. The main difference in calculus and the discrete mathematics is the variables, or the type of data which we study in these two fields. So in calculus, all of our questions and all of our numbers and data is in continuous form, and in discrete mathematics we study that in discrete form. So that is the main difference in calculus and discrete mathematics. So from now on, in discrete mathematics we will be looking on to discrete structures, not the continuous structures. And the main difference between continuous and discrete is that continuous is can be infinite, and discrete is always a finite number, is concrete, and you can count the numbers in the discrete when it's a discrete data, and in continuous you cannot count because it's simply infinite. So that was the main difference. Now let's jump towards the sets. So what is a set? A set is an unordered collection of objects. So in a set the order does not matter. So for example, here at the bottom I've written v equals, so this is a set. That is how you denote a set. This is we place in open curly brace, and then we write each individual element of a set, and then we separate them by inserting a comma, and then we close the curly brace, and that this form of denoting or describing a set is known as roster method. So that is an unordered collection of objects. So there is a, e, I, o, u, so that can also be u, o, I, e, a, so that the order does not matter in a set. So a set is an unordered collection of objects called elements. So each individual each individual, you can say the number or the alphabet in the first set I have denoted here is called an element of a set, or member of a set. So it is either called the element or the member of a set. A set is said to contain its elements. So this set is being contained in these in between these two opening and closing curly braces, and we write a. So therefore in general the in each individual element of a set is denoted by a small letter. So conventionally, or you can say by the rule of discrete mathematics or sets, you denote each individual element of a set by a small letter, for example a, and you describe a whole set, or you denote a whole set by a capital letter. For example, in these examples, the first one is a set that contains vowels, so 5 vowels, and the second one is the set which contains positive odd numbers less than 10. So these are the two sets. Each of them have 5 elements within it, and first set is denoted by V and the second one is denoted by O, and each individual element of these sets will be denoted generally by a small letter, and this whole set is being denoted by a capital letter. So this way of describing a set is known as the roster method. Ways of writing a set. So there are many other ways you can describe a set. So that one was the roster method, where you just enlist the whole numbers. Where you just enlist the, or where you just write each individual element in a set. So that is finite, and you write the you don't miss any element. So you write all the elements in a set. And now you have ways of, so you have another way of describing a set is to use a set builder notation. So you have so you don't, in this notation, you don't have to write each and every element of a set. What you do instead is you write, so you basically give the meaning, or you put so you basically put the logic into the opening and curly braces. So for example, here I have written that O equals, so I have opened the curly brace x, so x will be the all the elements in that set, such that, so this slash means such that x is an odd positive integer less than 10. So all the elements, so x is, so small x is denoting all the elements in a set, and it is saying that it is x is an odd positive integer. So odd, it is odd, and as well as it is positive less than 10. So basically what it is saying is, it's saying the same thing as I've written here, that O equals 1 3 5 7 9. It is saying the same thing, but this one is denoted in as using the roster method, and this one right here is denoted by the set builder notation. You can also write it as O equals opening in brace. You can write it as x belong to. So this e lookalike symbol is known as shows the belonging of an individual set to a set, or an element to a set. So x belongs to z plus means positive integers, such that x is odd and x is less than 10. So it is saying the same thing as the former set, but it's more short, and it's more, you can say, precise and efficient as well. After this, I want to discuss when are two sets equal. So two sets are equal if and only if they have the same elements. So and the order does not matter in it here too. So for example, you have, if I go to the previous slide, you have A E I O U, and then the second, for example, the second set was U O I E A. So the order does not matter, though these two sets will still be equal because they have the same elements. And then, so when they have the same elements, the number of elements are the same, or you can say the cardinal number is the same, the power, so everything will be the same because the elements are the same, but the order is different, which does not matter in a set. So that is why this condition, when this condition approves, the two sets will be same. And in a, you can say the in the mathematical form, you can write it as so this so what is written here is an upside down A. So that means for all x, when x belongs to A and x belongs to B, if and only if x belongs to A and x also belongs to B. So that means this. So we write A equals B means that A is equal to B, and if A and B are equal sets. Alright guys, so that was it for today. I'll do another lecture tomorrow, so goodbye.